The question is, which of the following statements is incorrect? There are four statements. Statement A, disproportionation reaction takes place for the hydrolysis of xenon difluoride, that is XeF2. Option B, in the hydrolysis of phosphorus trichloride PCl3, tautomers of POH taken thrice phosphorus acid are formed as a final product. Option C, in the hydrolysis of NCl3, HOCl is not formed. And option D, CH4 is inert toward the hydrolysis at normal condition. Now we have to check which statements are incorrect out of given four statements. Option A is a disproportionation reaction takes place for the hydrolysis of xenon difluoride. Now, this statement is incorrect because when xenon difluoride undergoes hydrolysis, it gives the products like, look at the reaction screen, 2XeF2 plus 2H2O gives 2Xe plus O2 plus HF. Now, in this reaction, oxidation state of xenon is +2 here at this condition. And now, xenon is formed at the product which is having zero oxidation state. Oxidation state of xenon in XeF2 is +2, whereas oxidation state of xenon in product is 0. What is change takes place here? This is only decrease in oxidation state, and that is called a reduction. And therefore, no disproportionation reaction takes place. Only single product of xenon is obtained, which is a reduction product, that is evolution of xenon gas only. Therefore, this reaction is not a disproportionation reaction. But when it will be disproportionation, if there is another product of xenon is obtained, then there will be a disproportionation, otherwise not. Therefore, given statement, disproportionation reaction takes place for the hydrolysis of xenon difluoride is a wrong, not correct statement. Now, second option, in the hydrolysis of PCl3, tautomers of POH taken thrice are formed as a final product. Now, if we write chemical reaction of hydrolysis of PCl3, then the reaction becomes PCl3 plus H2O. It gives H3PO3 plus 3HCl plus 3HCl. Now, if we look at this reaction, then hydrolysis reaction gives phosphorus acid H3PO3 plus 3HCl. Therefore, there are two products, not only the phosphoric acid or its tautomers. If we see the tautomers of phosphorus acid, then let us draw the structure of phosphorus acid. This is structure of phosphorus acid H3PO3. Here in this structure, if we write the tautomers of this phosphorus acid, that is due to when delocalization of these bonded electrons takes place toward phosphorus and pi bonded electrons are shifted toward oxygen, then the oxygen abstracts this proton and it gives structure of phosphorus acid, and that structure is having 3 OH group. That structure is having 3 OH group rather than to have 1 P double bond O. This is a tautomerization. PO group is converted into POH. This is not only the product. It gives just tautomerization. One form is converted into another form, and therefore this statement is again not incorrect statement. Only formation of H3PO3 is not there. Along with that, there is a formation of 3HCl. Now, let us go for another statement. In the hydrolysis of NCl3, HOCl is not formed. We'll just write the chemical reaction for this. This statement is again incorrect, because in the hydrolysis of NCl3, there is a formation of HOCl, hypochlorous acid. There is a formation of hypochlorous acid. It gives hydrolysis of NCl3 gives NH4OH plus HOCl plus HOCl. Plus HOCl. Now, in this reaction, actually there is a formation of hypochlorous acid, but in our statement, it is given as not formed. Therefore, the statement is incorrect. And fourth statement, CH4 is inert toward the hydrolysis at normal condition. This statement is correct because CH4 methane is a first member of alkane, and we know that alkanes are aliphatic saturated hydrocarbons. Being saturated, it is inert. It is also known as paraffins, means they are less reactive at ordinary or normal condition. Therefore, out of these statements, D option is a correct option. D option is a correct option. Next question is, choose the correct order of boiling point. There are 4 orders. H2 is having less boiling point than He. BOH taken thrice is having less boiling point than BOMe taken thrice. Next, third option, NF3 is having less boiling point than NMe3, and fourth option is CCl4 is having less boiling point than SiCl4. Let us see one by one which order is correct. First order is Incorrect. This is because H2 is a diatomic molecule having more larger surface area than the helium atom. Helium is a monoatomic gas. Helium having a complete duplet of 2 electrons. It is a single and having a spherical atom structure. It is a very small than the hydrogen molecule. Because of the complete duplet, it is having very less polarizability, and therefore this statement is incorrect. Actually, hydrogen having more boiling point than helium. Now, if we look at another structure, boiling point of BOH taken thrice is boric acid is less than BOMe taken thrice. Actually, hydrogen borate or boric acid is a solid crystalline structure powder, and BOMe taken thrice is a colorless liquid. Now, if we see the sequence, if we heat boric acid, hydrogen borate, then powder solid is converted into, I will write the chemical transformation here. If it is solid boric acid, BOH taken thrice, BOH taken thrice. If it is heated, then first it gets fused. First it gets fused. After that it becomes liquid. And if the liquid state BOH taken thrice is again heated, then it starts boiling and then vaporization. Means for boiling of boric acid, first we have to liquefy it and then we have to boil it. Means it will take more heat, excess heat to boil it. Then the BOMe taken thrice. Boiling point of BOH taken thrice is greater than BOMe taken thrice. Another reason is BOH taken thrice forms hydrogen bonding. I will write the structure of BOH taken thrice. Boric acid, this is a boron at center. Here it is OH. This particular OH group is a hydrophilic that forms hydrogen bond with water. 3OH group forms 3 hydrogen bonding with water molecule, and to break that additional hydrogen bonding, it will take more energy, heat, and therefore to break that OH bond, hydrogen bond, it will take more energy, and therefore boiling point of OH3 is greater than OMe taken thrice. This statement is also incorrect, as it is given exactly opposite in the given question. Third option is boiling point of NF3 is less than NMe3. Now this statement is correct statement because NF3 is having less molecular mass and Me3 having a higher molecular mass, bulky molecule. So it will take more energy. Greater energy is required to break the bonds of NMe3. Again, as we know that if molecular mass increases, boiling point also increases. Therefore, this statement is correct statement. And fourth option is CCl4 having less boiling point than SiCl4. This statement is again incorrect statement, because as we know that electronegativity difference between carbon and chlorine is greater than silicon and carbon. Therefore, in CCl4, the bonding is more compactly arranged and it will take more energy to break it, and therefore boiling temperature, boiling point of carbon tetrachloride is greater than SiCl4 is the correct order, but in our question it is exactly given opposite, and therefore the statement is incorrect. Now in another question is, which of the following diagrams indicate the formation of pi bond? In first diagram, the diagrams are as like this. Diagrams are as like this. In given diagram, the overlapping shown is like this. Overlapping shown is like this. Now here this type of overlapping is axial overlapping. This type of overlapping is axial overlapping, and axial overlapping forms sigma covalent bond, and therefore first option is not able to form pi bond. In second option, there is one p orbital and one s orbital. Actually, this type of overlapping is not possible. But when s orbital overlap with p orbital, that form again sigma covalent bond. That is again the head-to-head, the axial overlapping, and hence this forms covalent bond, sigma covalent bond. Therefore, second option is again incorrect option. Now, what about third option, C option? The diagram given is like this. This type of overlapping is shown there. In this type of overlapping, here the overlapped region is not lateral, not side by side. It is again shown that the axial type of overlapping, and therefore this is again not going to form a pi bond. But when pi bond is formed, when in B option, when the orbitals they overlap with each other laterally. How? Let us have some diagrammatic orbital picture. Control. Yes, like this. when these orbitals, particularly this and this and this and this, when they overlap side by side laterally like this, look at this, this type of overlapping is possible in the D structure. This is called side by side or lateral overlapping and forms pi bond. Therefore, D option indicates the formation of pi bond. Thank you.